Hey guys, welcome to this video on the product rule. So when is a product rule used? So suppose you have a function y equals f of x times by g of x. Then what the product rule says, it says that dy by dx is equal to f prime of x, i.e. the derivative of f, times by g of x, plus f of x times by g prime of x. Okay? So it works for functions that are comprised of two functions multiplied together. So let's consider another way of looking at it. If we have y equals uv, then in this case dy by dx is equal to u prime v plus uv prime. Okay, so that's just an easier way of remembering it, and we'll have a look at some examples and we'll break it down in this sort of way. So let's have a look at some examples. So example number 1, y equals 4x cos x. 4x cos x. So in this case we have two functions multiplied together, i.e. 4x is multiplied by cos x. So therefore what we are going to do is we're going to split it up in such a way so that u is equal to 4x and v is equal to cos x. Then what we are going to do is we're going to differentiate each one respectively. So u prime is equal to 4 and v prime is equal to the derivative of cos x is minus sin x. Then looking at the formula for dy by dx, it says that we have to multiply u prime by v, and then we have to add u multiplied by v prime. So dy by dx is equal to 4 times by cos x, which is 4 cos x, take away 4x times by sin x. And the reason why it's take away is, of course, we have the minus sin x. So example number 2, y equals 6x cubed e to the 5x. So again we can see that it's a product of two separate functions. We have u is equal to 6x cubed and v equals e to the 5x. So again let's go ahead and differentiate each one. So 6x cubed differentiated is 18x squared, and e to the 5x differentiated is 5e to the 5x, just by basic chain rule. Then the product rule above tells us that we have to multiply in diagonal fashion, and we get 18x squared e to the 5x if we multiply u prime and v together. And if we multiply the other two together, we get 30x cubed e to the 5x. So let's have a look at example number 3. Y is equal to 4x into 5x squared plus 1 all cubed. So here we can see that we have a product of two functions. One of the functions is 4x and the other 5x squared plus 1 all cubed. So let's start off by writing u is equal to 4x, v is equal to 5x squared plus 1 all cubed. And of course we need to compute their derivatives. So u prime is equal to 4. And v prime, that's a little bit more tricky. So you can see here that you have a function within a function, and so it requires use of the chain rule. So let's just draw a little bubble here and try to compute the derivative of v. So let's just say y is equal to 5x squared plus 1 all cubed, and we are going to have to use a chain rule to calculate dy by dx. So u is equal to 5x squared plus 1, and f of u is equal to u cubed. And so if you substitute u into f of u, you'll see that you end up with the function y. So u prime is equal to 10x, and f prime of u is equal to 3u squared. And if you watch my video on the chain rule, you'll see that you have to multiply together u prime and f prime of u, and you end up with dy by dx is equal to 30x all into 5x squared plus 1 all squared. So this is now our expression for v prime, and we can go ahead and substitute that right into there. So let's just write that down. We have 30x all into 5x squared plus 1 all squared. Now remembering that we are applying the product rule here, and we have to multiply diagonally and then add together. we end up with dy by dx is equal to u prime times by v, which is 4 into 5x squared plus 1 all cubed, plus, and then of course v prime times by 4x, which is 4x times by 30x into 5x squared plus 1 all squared. Tidying that up a little bit, we end up with 4 into 5x squared plus 1 all cubed plus 120 x squared into 5x squared plus 1 all squared. Great stuff. Thank you very much for watching this video on the product rule, and be sure to subscribe for more videos like this.